So we're doing the gas sensor because we need to be able to detect if there's any harmful gas on the planet where our Martians will be. We're going to be using an Arduino with obviously the gas sensor and 9-volt batteries to make it portable so that we can move around we can have multiple and move them around the planet to make sure most areas are safe. We're doing this because the planet can be unpredictable with what gases are on it. There could be toxic ones, there could be good ones, we don't know. But it's always good to have this sensor in precaution.
Okay, so the LCD. So, what's our plan with it?
Like, I don't know how we're gonna display the information, like from the sensor to all the people on board the ship and stuff.
Should we use maybe an LED?
Yeah, I'd say an LED is good because the sensor ranges from I think it's 300 to 752 as hostile area.
So should we just use a simple stoplight system red, green, blue? Red, green, yellow.
Yeah. What do you think, James?
I don't know. I think we've used an LCD screen for the rest of them, and it's worked well. I don't see why we shouldn't use it for this too.
I just think that's a little complicated. We could just keep it simple. I mean, we really just need just a 3-step, it's good or it's not good or it's kind of good.
Plus, we'd be connecting a lot of things into that LCD screen, and it might get jumbled up. Like if there are several issues, it couldn't display all of them.
So it might just be too complex for the nature of what we're doing. We could also hook it up to maybe a speaker of sorts, just in case, just to let the team know, in case they're not looking at the sensor module.
Okay.
Yeah, that sounds like a great idea. But do you guys know where my stapler went?
I have no idea, but you care for some Jello?
I'm about to crash out.
I think this design is pretty good, guys. But Roman, what are you doing?
Roman,
What?
stop!
Roman, that's genuinely disgusting.
What do you mean? It's Jello. I love Jello. I love Jello.
Disgusting with Roman. Eating the Jello that they put in my stapler, they all better count their days. I'm coming for them. I don't get the problem. I love Jello. I don't see the problem at all. And it's just Jello. Maybe they should try it sometime.
Okay, so Tyler, what does the gas sensor output like?
So right now it's like 300, an integer, 300 is 0, and then 7, 42 I think is the max it can ever get to.
Okay, so should we go over would over 60% be very concerning or
Yeah, I'd say so.
Okay.
Would you say so, Austin?
Yeah.
Yeah.
What do you think the threshold would be between safe and concerning, where you'd have to send somebody to check on it?
I'd say 0, absolutely no gas is present. I'd say that's good. That's safe.
Yeah, we need this is definitely something very it's if there's any bad gas, then there is concerns.
Yeah.
And then it needs to be in yellow zone.
Yeah, I'd say so.
So anywhere from 1% up to red is yellow.
Because even 1% gas can cause large problems for us.
Yes.
Yeah. And then anything above 60%, then
Someone's gonna die if we don't get things checked
it's
out.
over for them.
Yeah, it's joking.
Yeah.
Makes sense. All right.
So here are two 9-volt batteries which power the system, the Arduino board, and its controllers. We have two resistors here and here. They limit the charge going through so as not to overload the LEDs or the other sensors. The LEDs are used for 3 different purposes, green being safe, yellow being somewhat dangerous and needing to be monitored, and red being critical. So this is 0 concentration, this is 1 to 60, and everything over 60 is critical.
Nice. As you can see here, the Arduino functions as the brain of the circuit, as well as providing the power through this USB connection. It interfaces with the breadboard, which just keeps everything together and organized by putting everything onto a grid that just snaps in, so that electrical conductives are fine. And this interfaces specifically with the gas sensor and the piezo. The gas sensor measures a presence of a gas through the electrical conductivity of the air sample it takes. And the piezo produces sounds through electrical input.
The LEDs are going to be used because they're a lot simpler than an LCD screen, a lot more compact than an LCD screen. And we have 3 different ones, green, a yellow, and a red. The green is for when there's no gas detected, everything's great. Well, no toxic gas detected. Yellow is going to be when there is a little bit of toxic gas detected, but not enough to be fatal or to injure any person. And then red is for fatal gas amounts, or fatal amounts of gas for people and animals that are on the planet.
Well, I'm trying to get like the maximum values of like the sensor with like the smoke. Oh, really? Yeah, and so far, working out pretty well. We got seven. The max right now is 729. Okay. And by the looks of it, it's not going any more up. So by the looks of it, that is our max.
Nice.
Yeah.
Good.
Hey Tyler, how does this work?
So basically, the first thing that we did is that we initialized our static variables to define the min and max of the sensor, right? And then we set up all the pins so that we have the analog 0 pin as input. We set up the console, and then we also start up the pins 2 through 5 as output. Then we got the loop, and basically this just like runs every 100 milliseconds. And we get how it works. We read the analog like 0 pin, get the sensor output, and then we get like a level to determine if it's safe or not through the analyze function, and then display it on the LEDs
It will
and
play a higher
the
tone if
piezo
it's
if
at
needed.
level 2. The piezo will play
Then next we got the analyze
overtone
function.
if it's at
This
level
basically
1,
just
and
determines
then
like
if it's
an
at like
integer
level
value
0, then it just won't
based
play
on
anything at all.
if it's like equal to the minimum or half of like 60% of the max and so on. And then display LED function. Basically what this does is according to the level, it'll turn on the LED that's like associated with that level and turn off all the rest of them. And finally, play on the piezo. If it's level 1, so it's like
All right, so here we have the two batteries in the circuit. They lead up to the Arduino board. The gas sensor is also hooked up to the Arduino board. And the Arduino board here is hooked up to these two LEDs, which will lead back through the ground and back into the gas sensor through this resistor and this resistor. And also, out of the Arduino board, it will send the output that will go to the sound to alert about gas concentration. And that will lead back to the battery and back to the gas sensor. Thank you.
Carson, can you explain how the sensor works in the simulation?
Sure. So this is the gas sensor right here. It's connected to 3 LEDs and a piezo. And when this harmful gas gets close, it makes a sound. And that sound would also send an alert to any crew members saying that the dangerous gas is in the area so that we could seal off any blockages that there are.
we ran into a problem, and we don't know why the gas sensor's not working. Let's see. Bro, it's not changing. Austin,
What?
what is going on here?
I don't know.
What do you mean you don't know?
It looks like you have the gas over the sensor.
Yeah, but it's not doing anything. When I move it, it's supposed to change when it gets closer.
Well,
But it's just putting out that output.
1,000.
Austin.
Man, I don't know.
Oh my gosh.
Maybe you did the coding incorrectly.
I'm not. I don't do
Maybe
that.
the wiring's wrong. I mean, it looks
Yeah,
like you have
probably the
an L right there. It's an upside down L.
That's really funny, Austin.
What, you don't like the upside down L?
No, not really.
Oh. Man, I'm so tired of Tyler's crap. I'm not the one who's in charge of doing the coding. He is. And then saying he's perfect. We're all human.
Austin, what are you doing?
Oh, hey, Roman. So I'm looking at our gas sensor setup and how we have our batteries in parallel so that they will last longer. How we have a gas sensor, obviously, to detect the gas. We have a piezo, which we're going to be using to alert the workers. And then we have these LEDs because, one, they're simpler, and two, we're going to be using them to detect the levels of gas.
So basically, after some like experimenting, we figured out that we just didn't have the gas sensor wired correctly. But now after we added the resistor and connect all the things, it works fine.
So what did you learn?
I learned that the range of the gas sensor is about 10 centimeters, so we would want several of them in each room to make sure that there's no dangerous gas.
So Roman, what did you learn?
I learned how to find the maximum and the minimum of a sensor.
What did you learn?
I learned that the gas sensor works off of resistance to the gas. So when the gas is more not potent, but like in larger quantities, the resistance of the sensor goes down, which then gets transferred into an electrical signal to send to the Arduino.
Hey Tyler, what did you learn?
So I learned how to like set up the sensor to make sure that like it outputs like the right values and stuff, and make sure that it detects the gas.
So Charles, what did you learn? I learned that gas sensors use the electrical conductivity of the gas they sample to measure whether or not a certain aerial gas is present in the sample.
Well, when I was researching the Arduino board and the sensor and all of it, I learned about how the sensor itself works. So it actually takes a current and runs it through the air or whatever gas you have and measures concentrations and totals them up into things that aren't air. So that includes methane and flammable gases that should be dangerous to the human body. So what did you learn?
Oh my god! Over the course of this project, I learned that it's very important to make sure that there is like no methane present in the air whatsoever. Because even a small concentration of methane can cause very detrimental long-term health effects to people.